نحاول الآن نبدأ التسجيل كمان إن شاء الله اليوم. يعني السلايدز إذا السلايد يظهر نكتب نفسنا. So, Bismillah ar-Rahman ar-Rahim. Last time we talked about association analysis. We introduced concepts like item set, support count, support, confidence. Then we applied the support and confidence on association rules for evaluation. So we discussed also about the computational problem in terms of frequent item set generation. So we have the two set approach for association analysis. You first have to do frequent item set generation, just generating all item sets whose support is greater than or equal to minimum support threshold. This will be like defined to you or given. So a rule generation just generate high confidence. In other words, it is greater than or equal to minimum confidence threshold. So we talked also that frequent item set generation is still computationally expensive, and the book also talks about this. So if you have like a frequent item set L and its length, like the number of elements or items there in this item set is K, so you have 2 raised 2K minus 2 candidate association rules. We will see this as an example, so you will digest what we talked about. So we would like to find all association rules satisfying minimum support and minimum confidence requirements. The solution that we are going to talk about today, we are going to use a priori algorithm to generate all frequent item sets. Then the next step, we generate association rules from frequent item sets. So I brought an example to make it clear. So for a priori principle, all non-empty subsets of a frequent item set must also be frequent. Any superset of a non-frequent item set must be non-frequent. Okay. This one, repeated word will be deleted, so I will update that one, inshallah. Okay. So how is the a priori property used in the algorithm? So now we talk about the two-step process, and before that we introduce like annotation to make sure that everyone understands. Once we go to the example, we will go to that example step by step. So let L sub k is the set of frequent k item sets, and C sub k is a set of candidate k item sets. And this notation or this symbol just denotes the join operation. So we have two-step process. The first is called the join step. assuming that for the index it is greater than or equal to 2. We will explain why it is greater than or equal to 2. So we would like to generate C sub k by joining L sub k minus 1 with itself. A priori assumes that items within a transaction or item set are sorted in lexicographic order. We will have it once we go to the algorithm to explain these concepts. This just to show you before we start. So once we go to the example, you will grasp everything. Let L sub 1 and let I sub 2 and I sub 1 be item sets in L sub k minus 1. Okay? Now, this join is performed, be careful, where members of L sub k minus 1 are joinable if their first k minus 2 items are in common and I sub 1 of k minus 1 is less than I sub 2 of k minus 1. Okay, I will go over it, inshallah. So I give you an example. Suppose you have two item sets, okay? The first one is 1, comma 2. The second one is 1, comma 3. We know that 1 is equal to 1. Fine? So this is in common. And we know that 2 is less than 3. You see my point? So this is just to give you an example once we take the join operation. So we have the join, then the prune step. We would like to reduce the size of C sub k. So a priori property is applied as follows. Look here, we have candidate. I have a set of candidate k item sets. Am I right? So each candidate item set has what? K items. Okay. Now, any k minus 1 item set, this is the property of a priori, will be applied. Any k minus 1 item set that is not frequent cannot be a subset of what? Frequent k item set. Therefore, if you have any k minus 1 subset of a candidate k item set is not in L sub k minus 1, then the candidate cannot be frequent either, and so we remove it from C sub k. This is called what? Subset testing. It is performed fast by maintaining a hash tree of all frequent item sets. We'll have example. Now to gather all these concepts. So here is, this will be better. So now suppose you are giving this transactional data. Now we have a minimum support count threshold, which is what? 2. Fine. What is the minimum confidence threshold? It is 70%. Okay. So now this is like given. Now we have this or these transactions. Pay attention to something. We said that about lexicographic ordering of items as its assumption by a priori. Am I right? Look at the numbers here. I1, comma, I2, comma, I5. we know that 1 is less than 2 and 2 is less than 5. So there is a like lexicographic ordering. You know my point? Also, we know that for this one as well, 2 is less than 4. Check every one of them. You will understand what I'm saying. 1 is less than 2, less than 3, less than 5, and so on. So now we scan the database for count of each candidate. So look at C sub 1, meaning look, we have one item set here, one item set, one item set, one item set. So it has, each one has one item. Fine. So we start like this. Then we count the occurrences, or we call it support count. So for I1, we have how many of them? 1, 2, 3, 4, 5, 6. So we write it here. The second one for for I2, how many do we have? Could someone write? Okay, or check, let me know. Okay, yes. At which transaction? So we have what? Here. First we go here, 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 here. 3, 4, 5, 6. I missed one. Yes, this one. So we have 7. And so on. You count. For I5, to emphasize, how many do we have? 1. Yes, good. 2. Yeah, as good. We have to verify, because these are calculations, so sometimes you might miss something. So you have to be careful. So now we identified, or we have C sub 1, the candidate 1 set of candidate 1 item set. Fine. Erase. Then from this candidate set of 1 item, each of 1 item, so we compare candidate support count with what? Minimum threshold. So 6 is greater than or equal to 2. If yes, you include the item set in L sub 1. Meaning what? The truly set or frequent item set, each with 1 item. You know my point? So 7 is greater than or equal to 2. Yes, we include it. 6 is greater than or equal to 2. Yes, we include it. So you notice that we have included every item set here. So those are frequent 1 item set. So we have how many of them? 5. Am I right? So then after finding L sub 1, I have to do join. I join L1 with itself to find what? C, the candidate. C sub 2, a set of candidate 2 item sets. You know my point? So now we do the join. So let me go first. So I do this one as follows. I1 with I2, I1 with I3, I1 with I4, I1 with I5. Then I2 with I3, I2 with I4, I5. Then I3 with 4, 3 with 5, 4 with 5. You see my point? So I did it here. 1 with 2, 3, 4, 5, 2, 3, 4, 5, 3, 4, 5, 4 with 5. That's it. Now, once I am here, before I scan the database to count, to find the support count of each candidate, I have to do the following. I have to do the two-step for a priori, which is what? I did the join, I'm done now. I have to do the second one, which is what? What is the next one? We said. Yes, good. We prune now. We prune here. Good. So here is the following. We have two item set. Am I right? Find one item subsets of each one. So we have a set with what? I1. Do you think that I1 is here? So yes. What about I2? So we have, remember this one, we have I1, I2, I3, I4, I5. Am I right? Keep it in mind. If for each two item set in the candidate set, each subset of one item set appears in L1, so you take this item set. If one, I mean by each, every one item set of each two item set. So for example, I have how many one item sets for this one? I have one or two. Am I right? So one appears in L1. Am I right? Go back. It appears here. Am I right? I2 appears. So I move this one here. I didn't yet talk about support count yet. I didn't do, I'm talking just about applying the property. The second one, the pruning. Fine. Now for this one, we know it appears in what? The table for L sub 1. Am I right? So subset I1 appears, subsets I3 appears. So I take this one here. And they do the same. You find that everyone goes. Because all subsets of one item appears in what? L1. So I include this one. Now, once I include it, I have to find the support count. I1, 2. Go back. I1, 2. Where is this one? Where is the database? Okay, we go to the database. Okay. I1, 2. Remember. Okay, yeah, here it is. So I1, 2 appears how many times? It appears 4 times. Am I right? Yes, good. So you have 4 here. And you do the same for the remaining. What about I3, 5? We go back as well to check. We said what? I3, 5. Am I right? So I3, 5. Okay. So you are saying 1. Okay. We will see. Yes, as here. What about I4, 5? We go back, checking. Do they come together in any of the transactions? No. So done. So it is 0. Yeah, we make it 0 because we have numbers. Support counts like maps to numbers. You know my point? There is 0. It is like when you add numbers, you cannot say A, B, C. You cannot mix with the strings. A number plus a number is a number. You know my point? Keep it in mind for consistency. Now, once I have the candidate set, each candidate of size what? Or has 2 items. This is 2 item set, meaning it has 2 items. Okay. Now I do the following. To construct L sub 2 frequent 2 item sets, so I compare each. This one is greater than or equal to 2. Yes. So, and this one also. Say this one is excluded. This one. This item set will be excluded. This one. Because its support count is less than 2. This one. And those as well. Those will be not included in what? L sub 2. Please make sure that everything is fine. Let me know. Is it fine? So far, so good? Tamam. Now, look at this one. We would like to generate C sub 3 by taking the joining of what? L sub 2 with itself. Now, remember the lexicographic ordering. Okay. So, we do the following. Hopefully, I have an axis like this one. I will do it in front of you. Yeah, this one. So, this is L2 with itself. Am I right? Pay attention to this one. This one, the first one, is like this one. Am I right? This one should be less than the second one. So we skip this one. Fine. Now, look at this one. I1, because we have frequently two item sets, before 2 for each item set should be common between the 2 item sets when you take the join. The last one, meaning at position 2, should be less than the second item set. The second item in the second item set. So we explain it again. So this one is like this one. Am I right? But this one is less than this one. Am I right? So I take it. I1, I2, I3. I write it here. Next. I1, yes, common with this one. And this one is less than I5. Am I right? So I take it. I1, I2, I5. Next. Do you think this one is... I need your answer. I stop here. I go to the next one. This one is in common between this one. Do you think 13, I3 is less than I2? Skip, you know my point? So now with this one, we skip as well. Look at this one. I1 goes with this one. Am I right? I3 is less than I5. Yes, so we take what? I1, I3, I5. Here is. Let me know. I have no duplicates so far. Am I right? Okay. Next. We are here. Am I right? So I1 is like I2 or is equal to I2. Stop. Go to the next. You know my point? So I go here. I1 with I1 here. Yes, in common. But I5 is not less than I2. So skip this one. Skip this one. Skip this one. Nothing is in common between the first. So I skip. I go here. I2. Where is the common? Yes, this one. First with first. Is not. I skip. This one is equal to this one. And this one is less than this one. So I take it. I2, I3, I4. Here is. Next. I2, yes, is equal to this one. Also, I3 is less than I5. So I take it. I2, I3, I5. Here is. I go here now. I2 with I2. But I4 is not less than this one. I skip this one also. Now, I2 is common or is like this one. And I4 is less than this one. So I include it. I2, I4, I5. The last one. I2. You skip this one. We know why. This one as well. Also this one. Is it clear to everyone? Okay, we go back again. Good point. Look at the size of each or number of elements in each item set, specifically frequent item set. How many items do we have here? How many items? 2. According to the join, when we talked, here we have 2, am I right? For all items, or now, before 2, we have what? 1. If you have here L, you are taking join of K minus with 2, you would like to find before that, like number 1, here is its position number 1, am I right? And when you take the join here, I'm taking join here, so I would like to clarify something. I'm doing join of L2 with itself, am I right? So here is. So I have the same number of frequent item sets, am I right? So here, this one is 2, am I right? According to the join, we go back to explain it. That one is general. Look here, K minus 1. Suppose this one is 2. In our case, am I right? Members of L sub K minus 1 are joinable. This is the condition. Look at the condition. If they're first, K minus 2. You know my point? So K minus 2 would be what? 1. First items are in common. We saw 1, 2, 1, 3. So this one was in common with this one. Am I right? Equal, in other words. And this one is less than this one. You see my point? So then you join. There is a condition. Is it clear? You got the point? So we had there two, and so you look the first items. If you have k minus 1 joining between with itself, you look at k minus 2 items. It should be match. And k minus 1, in our case, which is 2, item is less than 3. This one. Am I right? So we go back again, explaining this to emphasize. We are here, am I right? So, good. So, k minus 1 is what? In that one. So we look at the first items. They should match. Now, this one should be less than this one. So I skip. I do not join. You know my point? I go next. This one should be matching. Why? Because I'm looking to first item or items between two. And the second item in each, like this one and this one, for the first, it should be less than this one. So I join. I 1, 2, 3. And this is what we did. So look at this one. Yes, in common, but this one is not less than this one. So I do not do join. Same for here. Same for there. Hopefully it's clear. Let me know. Do not be shy. You see the point? Once we do joining, immediately we do prone using the a priori property. Because we have C sub 3, we look into all two item subsets. So, yes, here are the three item sets. Am I right? We check what are the two item subsets. We have I1, I2. Do you think this one is here? Yes. So we are fine. I1, I3. Yes, it is here. I2, I3 is there. So I include this one later after pruning. I have to finish all, but this one will be included. You know my point? In C3. I check this one. I1, I2. Yes, is there. I1, I5. Yes. I2, I5. Yes. So after pruning, this one will be included, and you will see it, which is here. Now I go here. I take all two item subsets of each three item set, and I check with what? L sub 2. I1, I3. Yes, is here. I1, I5. Yes. I3, I5. Do we see it? No. So after pruning, this will be excluded. The three item set. Okay, we go next. What about this one? 2, 3. Do we see 2, 3? If you do not find any two item set from that 3 item set, you do not include it into what? C3. I23, I skip it because it is not there. I23, why this one is skipped? I23 is there. I24, yes. I34 is not there. Am I right? So we skip this one. Do not include it later. I23 is there. I25 is there. I35 is in the list or like the set or not? Let me know. So we exclude it. You know my point? So I exclude this, this, this. What about this one? What is the 2 item subset that is not in L sub 2? Which one? Good. Yes, you got the point. Good. Good. So now I'm left with this one. So this is just to speed up the computation, because if C sub k and k is large, this is a problem. So this one is easy to check. You see my point? It is like a check yes, no for each subset. It is fast, saving computational time. It is about complexity. Now I have to magnify this one. Full screen. Now after pruning, we have this one. Am I right? Go back here. Am I right? We include that one in C sub 3, the candidate set. Now we scan the database for these. We would like to count, to find the support count. I2, 1, 2, 3. 1, 2, 3. How many times? One, two, five. So 2. Now, good. Now we compare each with respect to the minimum support count threshold. This one is greater than or equal to this one, so fine. I take it here. Am I right? Now I do join again. Am I right? To find C sub 4. What is the join of this one with itself? Look, because each has like 3 items, their first 2 items should match in common. And the third items, the first one here should be less than this one. Am I right? So this one is less than, is like this one, and this one is less than this one. So I make it, which is what? After the join, I1, I2, I3, I5. Am I right? Here is. This one is right. Let me know if you understand this one. This one with this one, this one with this one, you skip. You do not do join. This one, the last one, the third item in each. For the first, it should be less than this one. So I skip here. This one is like this one, and the third position of this and this for this one should be less than this one. So I include it. I1, I2, I3, I5. This one, yes, yes, but this one is greater. I skip, and this one I skip. So I have this one. I'm left with this one. Am I right? So far, so good. Now to construct C4, I have to do the property, the pruning property. The next one, I check each 3 item subsets of this 4 item set. Look, we have I1, I2, I3, I1, I2, I5, and I2, I3, I5. I1, I2, I3 appears here? Yes. I1, I2, 5 appears? Yes. I2, I3, 5 appears? Let me know. So this one will not be included into what? C4. So C4 is what? Empty after pruning. And algorithm terminates. Have finding all frequent item sets. Okay, now we found the frequent item sets. Which are those? Am I right? From these, we generate rules. For each one, this one, how many rules could we have? 2 raised to 3 minus 2. We exclude empties. So 9 minus 2 is what? Sorry, 2 raised by 3 is what? 8. 8 minus 2, 6. Yeah, you're right, as what you are saying. Good. 2 raised by 3 is what? 8 minus 2, which is 6. Yes, good. Suppose you have the minimum confidence threshold, which is what? 70%. Now, for the first or either one of them, we start with this one. So we have I1, I2, implying I5, and so on. We have 6, you said. Am I right? So we calculate the confidence. For this one, we count the support, which is what? We use like support. Sometimes people use support count divided by support count. You see my point? So these, you have what for this one? Support. Suppose now we are doing with the support. You could do support count divided by support count or support by support. You know my point? So yes, some people use that and that. So this one. This one is what? Is this one right or wrong? I take this one all. I find the support, which is what? 125. Good. What about divided by support of I1, I2? That's good. So, good. So, ask yourself a question. Is this then greater than or equal to 70%? This is like 0.5 is greater than or equal to point. Yes. So, you exclude this one. Later, this rule, you will not include it. What about this one? I1, I5, I2. Do you agree with these calculations? You take all. I1, I5. Look here. We know this one. Am I right? For support, you take all. All. So look here. The support numerator is the same. You know my point? The difference is in what? Denominator. Because you are finding with respect to what? This side. Is this point clear? Good. Now for this one. I1, I5. It appears how many times? 2. So 2 divided by 2 is what? 100%. Is it greater than or equal to 70%? Yes, good. I will take this rule. Good. What about this one? Do you agree that this one is 2 divided by 2? Okay, explain it now. Oh, you do not see anything? Is there a problem? Like, do you mean like the screen or what is the issue? Let me know. Oh, the screen? Oh, black screen? Yes, for me, I see it. Let me, is there someone whom could see this one? Yeah, be careful. You have to do it from your screen. You have to refresh or, you know, my point sometimes I'm not sure about if it is the internet. So, okay, we go back. For this one, so far so good. Let me know. Good. Yeah, try to refresh. Yeah, we learn from you as well now. If we have something, we do it. So I2, I5, I1. We know numerator is the same too. What about denominator? I2, I5 appears how many times? 2. So 2 divided by 2 is what? 1, which is 100% now I'm talking. Is it greater than or equal to 70%? We will take it. And this is the same for this one. We do the same calculations. Let me know if you verify this one. Please do it so I make sure that you get it. We have done the previous. Please do this one. This one is right or wrong. Let me know. Good. Someone else? Is it fine? Good. Good. What about this one? Numerator is the same. What will it change is just what? Denominator. This one is what? Good. This one? Good. So now I took only how many rules with me? These. You know my point? So I take these. So just 3. You are right. Now I do for the other one. For the other frequent item set. The same calculations. The same. Please verify this one. Good. What about this one? Good. This one, practice, you calculate by hand. This makes it like clear for you. This one, good. This one and this one, let me know both. Good. Good. So for this frequent item set, did we include any rule? You ask yourself a question. Is it greater than or equal to? No rule will be selected from these. You see the point? So we only selected from what? From that frequent item set. You see my point, so? Good. Yes, you are right. All less than 70. Good. So we didn't select. This is just like we are done now with like a priori. Hopefully you understood like the priori. Well, so this one is like good for you. So you know to find like frequent item sets or apply a priori. Then I know that because item sets is like computationally expensive to find it. So a priori helps me finding like frequent item sets. Okay, so now suppose you have this rule. Those who buy tea also buy what? Coffee, suppose. Now, the confidence for this one, suppose, is what? 0.75. Meaning what? 75% or like, yes, 75% of those who purchased tea, or it depends on the context, or like tea, will also like or purchase tea, purchase coffee. Fine? Okay? Good. So in other words, we have like, it depends on the context. So 75% of these like having tea, also coffee. Okay? Now look at this one. This one is tricky. Keep it in mind to show you the drawback of confidence. Look at this one. For not tea, this one is greater than 90%. Like 93.75% of those who didn't like or purchase also like or purchase coffee, or 93.75 of these that not having tea also had what? Coffee. Okay. Now suppose for this one, 75% of those who like tea also like coffee. Suppose now you give a coupon or something, you know my point? But now you said to that guy, oh, I have high confidence. Fine. Now for those who do not like, they also had the coffee. You know my point? So it is misguiding the confidence. You know my point? It doesn't take this relationship. Keep it in mind. Like complement. So it is misleading. Am I right? You see the difference? So this is just to give you a flavor, like to show you like drawback of confidence. So if I know that those people who do not like tea also like higher percent of these also like coffee, I could bring the coffee, I put it there for those who didn't drink or like tea. You know my point? So this one is misleading. You know my point? Because I know that high confidence here, they will buy it most likely. You know my point? You know here? So why I put coupon or something here? You know my point? Those those most likely will get this one. Those might not be interested. You know my point? This one, I make sure that I have high confidence. I put it there. Or if I put the coupon, it would be better to put it here. Am I right? But I know because it is high confidence, most likely this is like close to like more than 90%. It is like 93.75. So I put it there, like the diapers example that we talked about. This confidence is higher than this one. Am I right? So yes, you take care of this one for those who didn't drink or like tea. You know my point. So to put coffee or to consider those people better than considering those who did like or drink tea. You know my point. So you do what you feel best with the coffee to increase your sales. So those are other metrics applied, not just the confidence. There are others. So for now, just in this class, we just want to show you how to find for association rule, how to understand if you are given like such a database of the transactions and items, how to find like frequent item sets, and then you generate rules from these. So we use a priori because it is computationally expensive to find frequent item sets generation. So this is the research in this one. It is like a classic data mining problem, I say. It's nothing like, how could I say, nothing new. You know my point? And I think there are algorithms, but not like before. When it came like as a hot topic, people used to publish. If you do something, it will be a contribution. You know my point? But now it is like you are on the top of the mountain. So if you do something, a contribution or additional stuff, it might be invisible unless if you do something like outstanding. You do a fast algorithm. You know my point? So easy and something like amazing. This is like a different scenario. So let me know if you have a question. So inshallah we will talk about homeworks. Next lab, inshallah, we will try use R applying a priori. We would like to see. You see my point? So we would like to check and then we go from there. It is better to see it in practice as well. This class is about explaining algorithms or AI algorithms in an easy fashion, hopefully. I'm doing my best to make it as easy as possible. At the same time, I would like it to be like excellent when applying these techniques. So inshallah, when you go like after this class, you could formulate problems, you solve it. You know my point? So you have tools. These tools will help you solving like complex problems, inshallah. Is there any question for today? A priori, confidence, support count, support, frequent item sets, and so let me know. بالنسبة لوقت المعمل، لما حاولت انكم تغيروه في كم واحد طلع على الوقت؟ يعني يفضل انكم تواصلوا مع الشؤون التعليميه، حاول معاهم، ارسلوا لهم ايميل بالموافقه جميعا. يعني ان شاء الله يعني ما بالنسبه لو كلكم يعني متفقين على الوقت، اكتبوا على البلاك بورد افضل. اكتب على البلاك بورد يصير نحن نشوف الوقت المناسب لكم، نحاول يعني ايش دائما ايش يعني نبغى راحتكم، ما نبغى نختار يعني وقت، وان شاء الله نحاول في اللاب نسجله، نسوي تسجيل افضل. بس لما نسجل مو زي لما تكون ايش يعني الان ما شاء الله كم واحد سال كم سؤال، افضل. انا اشوف انه ايش يعني لما تسال في تفاعل في ايش، وفي نفس الوقت لو عندك شغله حاول انك تكتب بيدك. التسجيل صح انه يعني ممتاز، لكن اي شيء علمي يبغى له باليد ممارسه، والتفاعل مع المدرس افضل. يعني في نفس الوقت عندك السؤال اسال على طول، افضل من انك ايش، يعني تشوف الشيء امامك يمكن ترى تكون ما انت فاهمه ولا شيء، او يكون في سوء فهم. فاحضر على الوقت على الكلاس، والتسجيل عادي حطه يعني شيء ثانوي، يعني ما هو شيء. تمام، كلكم يعني متفقين، خلاص اكتبوا على البلاك بورد. يبغى لي اشوف كيف، او ان واحد يعني ترسلوا ايميل لي وانا اشوف ان شاء الله احط، اشوف احاول ان شاء الله لو احط جوجل شيت ولا شيء يصير ايش، تدخلوا عليها وتحط، انتوا اقترحتوا الوقت المناسب، يصير انا ايش احط الوقت في جوجل شيت وكل واحد يسوي جنبه ايش، اشوف يا جوجل شيت يا ايميل. افضل حل كل واحد يرسل لي ايميل بنفس الوقت، صلى الله وبارك. افضل حل على ايميلي اللي هو tturkey@ku.edu.sa، افضل شيء وافضل حل. طبعا الموضوع لاب تايم، ايش الوقت اللي انتم قلتوا عليه؟ 11 اي ام، اليوم تيوزداي. السبجكت واكتب انه ما يعني موافق، ما يعني ما عندي مشكله شيء، لو واحد عنده مشكله امل انه يعني ايش يفيدني، عشان يعني ما نبغى يعني نتسبب يعني في مشكله صراحه. بالتاكيد افضل. العنوان للتسهيل لي، يعني عشان ايش تخليها سهله كمان افضل. واكتب بالعربي ما عندي مانع، يعني الوقت يعني مناسب. في في السب في البادي حق الايميل الرساله صلى الله. لو ما انت موافق واضحه، احاول احطها على البلاك بورد اسهل. موافق، ماني موافق على الوقت، واضحه. احاول اعد لانه العدد قليل، المفترض انه 15، ما ادري هل هو ينقص طالب. واضحه. تمام. وحسوي ان شاء الله اعلان announcement. ممتاز ما شاء الله، ممتاز، اختصرتها صح، ممتاز. او حطها في ليش اللي هي هذه، حطها في السبجكت وصلى الله وبارك، خلاص يعني نريحكم. عشان ايش اكتب يس I have no problem، I have no problem for صلى الله وبارك. ان شاء الله خليني اكتبها الان عشان اذكر. هذه في البادي. هذه البادي هي نفسها الآن. موفقين. لو في استفسار ولا شيء على البلاك بورد، وإن شاء الله الكلاس بعد اللاب نشوف ندخل على الكلاسيفيكيشن إن شاء الله. نبدأ كلاسيفيكيشن وحيستمر لكم أسبوع إلى أن نصل إن شاء الله للمواضيع الثانية: regression، dimensionality reduction والclustering unsupervised learning، وحيفيد برضه في الفيتشر سelection. بعدها نتكلم عن الريكومندر سيستمز إن شاء الله، ونشوف الديب ليرنينج نعطي له حقه كمان نفس الشيء مع الابلكيشنز في الداتا ساينس. ان شاء الله حيكون في جانب عملي. خليكم ان شاء الله يعني اهم شيء الجانب العملي، نبغاكم يعني اكبر قدر ممكن يكون في تطبيق، عشان ان شاء الله لما تواجهك مشكله بقدر الامكان نحاول يعني ايش نبسط الخوارزميات ان شاء الله. الله يوفقكم. بالنسبه لله ممتاز. بالنسبه للاب اللي جاي تمام. اللاب زي ما هو الوقت، بعد ما اتاكد انه كل الايميلات جات. ممتاز. ملاحظه يعني ممتازه. الى الان عادي، ما تغير شيء، ماشيه الامور زي ما هي. لكن لو الجميع موافق وامل انك يعني تكتبوا التاريخ على ليش، على هذه النقطه اللي ذكرها زميلكم ما شاء الله ممتاز. تحدد اليوم ابتداء من كم يبدا الكلاس حق يوم الثلاث، لانه هي اصلا يوم الاحد. فالاحد اللي جاي حنستخدم الار. البايثون نفس الشيء، حنعطي لينكس ان شاء الله للبايثون اللي يبغى البايثون ان شاء الله. بالنسبه اللاب يوم الاحد اللي جاي زي ما هو، ما تغير الوقت الى ان شاء الله. بعد اللاب اللي جاي لو في نفس اليوم اتاكدت انه قبلها جاتني الايميلات، يصير اتكلم في نفس اليوم الاحد نقول ايش، انه خلاص الجميع موافق، لانه حسب فيها برضو القسم افضل، الامور تمام. يصير بعدها ان شاء الله، لانه المشكله مش حكايه انه نغير الان. يمكن ان شاء الله لو رجعنا يعني حضوري ان شاء الله شخصي، هنا الاشكاليه يمكن تكون في قاعه ما نلاقي قاعه. فاهمين وش القصد؟ فعشان كذا انسق مع القسم، يبغى لها وقت. الى الان خليها زي ما هي، ما عشان كذا انا ايش متاخر في تغيير الوقت. اشوف القسم اتاكد الامور تمام، لان يمكن لو رجعنا ان شاء الله يعني بالسلامه وما في لاب، هنا حتكون اشكاليه كبيره صراحه. فنتاكد، وانا اشوف احاول نتواصل حتى مع الشؤون التعليميه ولو يبغوا منكم هم، يمكن هم يطلب منكم الطلب انه تغيروا الموافقه جميعا، يصير كلكم ترسلوا لليش للشؤون التعليميه. وافضل انكم انتم يكون من عندكم الارسال للشؤون التعليميه ولي كمدرس. عندكم الايميل حق الشؤون التعليميه؟ اشوف ان شاء الله اتواصل مع القسم وارسله على البلاك بورد. الشؤون التعليميه اللي هي كانت في الدور الثاني، اللي هم مع الجداول وما الجداول عندنا في الكليه. اشوف ان شاء الله قنوات التواصل معاهم، يصير يعني افيدكم ان شاء الله. وافضل شيء ترسلوا جميعكم الموافقه على الوقت المعين، وهم طبعا حيدرسوا الموضوع. انا بالنسبه عندي ما عندي اشكاليه، لكن اهم شيء لانه تعرفوا الكليه عندنا ايش اللابات وما شاء الله الكلاسات، فيمكن ايش لو رجعنا حتكون في اشكاليه. لا تشيلوا هم المشكله، نحن ماشيين تمام ان شاء الله، وانا حشوف ان شاء الله اتواصل مع القسم، ولو في شيء افيدكم ان شاء الله بالاتصال مع الشؤون التعليميه وايش المطلوب، يصير ان شاء الله انتم ايش تتواصلوا معاهم ونشوف بعدها. تمام، لانه الاونلاين ما في مشكله، الحضوري يمكن نرجع لما كنا عليه، يعني نقدر نشوف مرونه بعدها ان شاء الله، بس خلينا نقول ايش بشكل متاكد ايش عشان مستقبلا نتفادى شغلات، عشان لا حد يبرمج نفسه على، لان احنا مبرمجين على شيء معين. موفقين وفي امان الله. العفو.